Hi, I welcome you to my channel, The Outlier. In today's presentation, we'll be looking at how will we be using inbuilt functions of SAS to create additional variables. These are very simple inbuilt functions that SAS offers, which simplifies the entire process of data analysis. To do this, I'll be using a data set which is known as hard data set. You can access this data set from the library SAS help. Let me just click on this arrow. As I scroll down, you will be able to locate the dataset heart dataset, right? You can see very interesting variables here, but I'd like to draw your attention to height. And there's another variable which is known as weight. If I could just scroll down, yes, this is the variable weight. So using this variable height and weight, I will be creating a new variable called as body mass index. Let me just demonstrate the code for it. You can see here what we are doing here is we have taken the variable weight in the numerator and we are dividing it by square of the height, and finally we are multiplying it by a conversion factor 703 to obtain body mass index. And this I am creating, and this variable BMI I'm going to create and store in a new data set which is known as heart data set. Let me select this piece of code and let me execute it. There are 5209 cases and 18 columns. As I scroll to the right side, a new variable called as body mass index has been created. Now, this is a very useful variable, but the problem with this is that you have decimals. You have 3 to 4, sometimes even 6 different decimals. You have 6 different digits after the decimal point, which is a problem. So when you have numbers like 25.19552 or 38.201572.101, you have a lot of numbers, you have a lot of digits after the decimal point. Question is, can I round it off? Uh, SAS offers a very easy function known as a round off function, which helps us round to the nearest decimal point. To do this, what I'll do is I will be using the round function. I can open parenthesis. This variable BMI will be used as the input, and we can round it off to the nearest second decimal. Once it sort of rounds it off, what you can do is you can sort of create a new variable, and that new variable is BMI1. Right. As you scroll to the right side, you can see two variables. Not new. There's only one new variable, but you can see two variables. Please compare the variable BMI and BMI1. This is a bit difficult to comprehend. Many times we may not want to show the digits after the decimal point. Here, after rounding off, we are able to see the number. So this is a lot better, and many times while analyzing the data, we may choose to use the variable BMI1 rather than the original variable BMI. Now, there are a couple of other interesting functions that you can sort of use, and that is you can take a log of BMI. You can apply a log function, and within this you can pass the variable BMI. Now, one other thing that you can do is you can pass this function inside another function, right? So I'll be applying the round function, and I'll round it off to the two nearest decimals. So as you can see here, what happens here is the function log will be applied on BMI, and log transform BMI will be calculated. Now the round off function will be applied on the function log BMI, right? So let me just repeat this. I'm taking the original variable BMI and I'm applying the log function. I'll get the log transform BMI values. Now what am I doing? I'm applying the round function on the log transform BMI values. So this is another variable which you can sort of create. I'll call this as BMI2. Why am I creating this? Why am I taking the transformation? This may be a question in your mind. Many times for continuous variables, what happens is that the original variable, the raw data might not be normally distributed. However, when you apply a log transformation, the log transform values may follow a normal distribution, right? So this is where your log transformation and other important transformation like inverse transformation, sine inverse, cos inverse, and tan inverse, sometimes reciprocal transformation, Box-Cox transformation. You have a variety of transformations that can be applied. So I'm going to create the variable BMI2, which is nothing but a variable that I'm going to obtain after applying the round function on the log transformed BMI value. So it is a function inside a function. I'm passing a function inside another function. If I scroll to the right side, you can see here, this is the original variable and this is the BMI1, and this is after uh, taking the log transformation, you are able to see the variable BMI2. So you've been able to create two additional variables, BMI1 and BMI2, by applying transformation here. Let's make a move on to certain other useful functions. What you can do is basically you can say log 10. It basically means log to the base 10. Here you'll be passing the variable BMI. You can put a semicolon here, and this will be BMI 3. So the variable BMI3 is obtained by applying the log transformation for the variable BMI, right? Now, if I specify 10 here, it means that it is log to the base 10. You can see here, this is the variable that I'm getting. But again, the problem here is that after the decimal point, you can see around 9 different digits, right? It could be more than 9 digits as well. Many times we might not want to use or we might not want to display so many digits. So a very, very simple trick that you can apply is round off, right? Using the round off function, which we have seen just now, we have applied the round off function and we have obtained new values as you can see here, right? Many times what happens is that especially when it comes to temperature and such things, you can get a combination of plus values as well as negative values. You can get positive as well as negative values. Question is, can I take the absolute of it, right? So you can use the abs function, abs of function, and you can again use BMI. Now this is only for demonstration purpose because nobody's BMI here in this data set is negative, but I'm just applying it just purely for academic reasons. You can just call this as BMI 4. So this is the fourth version of BMI wherein I'm applying the absolute function on the variable BMI. Let me execute this, and as soon as I execute it and scroll to the right side, you can see this variable BMI4, which gives you the absolute value of BMI. Finally, you can also apply the int function. You can apply it, as the name itself suggests, it converts the variable BMI into an integer. So you can have the new variable as BMI, right? So you can create the new variable as BMI5, wherein I will be applying the int function on the variable BMI. Let me select this snippet of code and let me execute this. Let me scroll to the right side. As you can see here, this is BMI5. This variable has been created after applying the int function, which is nothing but integer function, and that integer function will be applied on the raw data, and you'll be getting the integer form of this particular variable. So I will just recap what we have covered today. We have seen how to apply a particular formula and use the original variable and create a derived variable BMI. After this, what we have done is we have seen a simple application of round off function. What round off function does is, as the name itself suggests, it takes the original variable and rounds off that particular value to the nearest decimal. You can specify 1 or 2 depending upon what is your requirement. Second thing that we have seen is how to apply a function on another function. So as you can see here, I'm applying the round function on log function. So if you can see here, log function is applied on BMI. The output of that will be passed inside the round function to generate a new variable BMI2. Finally, in line number 8, what I'm doing is I'm creating BMI3 by applying log to the base 10. I'm applying log to the base 10 function on BMI. Next very useful function is abs function, which is nothing but short form for absolute. And finally, we have seen how the integer function works. All these functions are inbuilt into SAS, and within a matter of seconds you will be able to create new variables. With this, I come to the end of today's presentation. I hope you have found today's video helpful. I thank you very much for watching today's presentation. I request you to subscribe to my channel and hit the like button. I'll see you in my next video.